Hi, my name is Madeline Shepard, and I am in Dr. Greco's 2212 physics class, fall of 2013. The lecture that I chose to record is soft matter, food, and cooking. And basically the 3 points that I'm going to relate to you are soft condensed matter, what is it and why is it soft, flow, viscosity and viscoelasticity, and phase transitions, how matter changes with temperature. Okay, so what is soft condensed matter? Basically, it's a material that is easily deformed, and typically it's in a mix of phases. So my example that I'm going to show is using mayonnaise. It's composed of egg and oil, both of which are more liquid than solid, so it doesn't flow on a dish. So it's kind of gross and solid, but it does have flow if you apply enough force to it, like a spoon. See how it's nice and flowy? This elasticity is formed by the droplets of oil inside the mayonnaise. So when the mayonnaise is stirred in production, energy is introduced into the system, and this can create compressed droplets, which causes a lot of surface tension. This system is characterized by the elastic modulus formula, which is G is energy over I cubed, or surface tension over R. And that is what Dr. Fernandez described as an amazing formula. He was really excited about it. Another way to relate this connection to the surface tension over R is to think of it like a spring. So, like Hooke's law is F equals K times X. If you think of it in terms of stress or strain, stress over strain, then sigma equals the force over the area. And in terms of the formula that Dr. Fernandez came up with, it looks like G of Y is equal to G of X over L. So that formula. The next thing I'm going to talk about is flow. A material is a liquid if the molecules can move around each other. So the fundamental quantity that governs this is the time that it takes for molecules to move around. So let's use the example of water. Here it is. At long times, water is a liquid, and molecules flow by each other. As you can see, the bottom of the glass, there's more water. But at short times, the water is a solid, which is the ice part, because molecules don't have time to flow around each other. At really, really, really long times, it turns into a gas, because molecules have plenty of time to flow around each other. And as a property that Dr. Fernandez pointed out, all liquids are solids at short enough time, so they're all viscoelastic. The last point that Dr. Fernandez talked about was my favorite. He talked about phase transitions and how in cooking you can change the phase of any material by just changing the temperature. So let's use the example of water again. When you heat it up, it turns into a gas. When you freeze it, it turns into a solid. However, if you look at eggs, it behaves the opposite of water. It becomes a solid when it's heated, so not a gas. This is because eggs contain proteins, and proteins are chains of amino acids. So how it works is the protein depends on the environment. When they're heated, it leads to longer molecules, which solidify at higher temperatures. Now, eggs contain many different proteins, such as ovotransferrin, yolk proteins, and ovalbumin, and they solidify at different high temperatures. This is why you can cook eggs so many different ways, like boiled eggs and fried eggs, over easy eggs, all sorts of different things. And each food material has different phase diagrams. So like meat cooks differently than eggs, of course, because it has different proteins. And then liquids, most liquids solidify at colder temperatures rather than higher temperatures. Here I'm showing the different phase diagrams that I talked about. This one is water. As energy and temperature increases, the water turns from solid to liquid to gas. This is eggs. As you can see, as temperature increases, so does solidity. And this is the different ways you can cook eggs according to temperatures. And this is the phase diagram of meat at different temperatures. Dr. Fernandez closed with stating that the physics behind food is still greatly unexplored. But he's still exploring it, and if you're interested in learning more, he's having another lecture in the spring, and it's all about chocolate. So definitely go to that because it's really interesting, and you get free chocolate. Thank you for watching. Have a great night.